Hello, grade 11 STEM. Welcome to General Chemistry 1. This module is developed and designed for senior high school STEM students. It tackles on topics about stoichiometry too. After going through this module, you are expected to explain the concepts behind stoichiometry, construct mole or mass ratios for a reaction in order to calculate the amount of reactant needed or amount of product formed in terms of mass, and appreciate the essence of stoichiometry in our daily life. For our pretest, number 1, calculate the mass of hydrogen gas formed when 95 grams of aluminum reacts with excess hydrochloric acid. A. 0.9 grams, B. 1.7 grams, C. 3.9 grams, D. 8.3 grams.
Number 2. What mass of aluminum is produced when 0.500 mole of aluminum sulfide is completely reduced with excess hydrogen?
A. 12 grams, B. 27 grams, C. 56 grams, D. 65 grams.
Number 3. Calcium carbide reacts with water to produce acetylene as shown by this reaction. Calculate the amount of water consumed in grams for the production of 13 grams of acetylene.
A. 9.0 grams, B. 18 grams, C. 36 grams, D. 72 grams.
Number 4. Which of this statement is not true? A. The mass of the reactant can be converted into the mole of reactants using its molar mass. Letter B. The mole of the reactants can be converted into the mass of reactants using its molar mass. Letter C. The stoichiometric mole ratios are used in calculating the exact amount of reactants required in a reaction. Letter D. The stoichiometric mole ratios are used in calculating the estimated reactant required in the reaction.
Finally, we have pretest number 5. What should be used to convert the mass of the reactants into mole of reactants? A. Symbol of the elements. B. Mole of the products. C. Molar mass of the products. D. Molar mass of the reactants.
Check your answers. If you did not get them all correct, do not worry because we will have a discussion of this topic.
As a recap, let's try to review the concepts in your previous lesson about stoichiometry. Study these problems and do your best to answer. Write your complete calculations and final answers on a separate paper. Calculate the amount of iron in moles that can be produced from 876.2 grams of iron oxide. Molar mass for iron oxide equals 159.69 gram per mole. The answer is 10.97 moles.
Number 2.
Determine the moles of sodium hydroxide that can be produced from 115.2 grams of sodium. Molar mass for sodium equals 22.99 gram per mole. The answer is 5.011 moles. Now for our lesson. Filipino youth have an average height of 5 feet. Like you, they may probably know their height in feet and in inches, but may not be in meters. This requires your knowledge in conversion factors, especially when you experience filling in forms that would require your height in meters. So you get the height in meters by dividing the value of feet by 3.28. So let's look at the example. We have 6.56 feet into meters. So you divide 6.56 divide by 3.28, which is equal to 2 meters. Likewise, in chemical reactions, the mole of the substances can be converted to mass or vice versa by using a conversion factor, but properly termed as stoichiometric ratios. You already used stoichiometric ratios in the previous lesson involving moles of the reactants and products. This time, we will involve mass of the substances in a chemical reaction.
Consider the production of ammonia by the reaction of hydrogen gas and nitrogen gas.
So here's the question. Letter A. How many grams of ammonia will be produced if 20.92 moles of hydrogen react completely with nitrogen? Letter B. How many grams of nitrogen are needed to produce 17.1 moles of ammonia?
To answer question A, how many grams of ammonia or NH3 will be produced if 20.92 moles hydrogen react completely with nitrogen? We are required to convert mole of hydrogen to grams of ammonia. What we need are mole ratio of hydrogen to ammonia, which is 3 is to 2, and molar mass of ammonia, which is equal to 17.1 grams per multiplied by molar mass of ammonia is equal to 238.5 grams ammonia. To answer question B, how many grams of nitrogen are needed to produce 17.1 moles of ammonia? We are required to convert mole of ammonia to grams of nitrogen. What we need are mole ratio of nitrogen to ammonia, which is 1 is to 2, and molar mass of nitrogen, which is 14 grams per mole. For our solution, 17.1 moles ammonia multiplied by mole ratio multiplied by molar mass of nitrogen is equal to 120 grams of nitrogen.
Let's try to answer another problem involving stoichiometric calculations. So we have magnesium chloride reacting with 2 moles of sodium hydroxide, producing magnesium hydroxide and 2 moles of sodium chloride. For letter A, determine the mass of sodium hydroxide required to synthesize 54 grams of magnesium hydroxide. Letter B, how many grams of sodium chloride is produced from 212.9 grams magnesium chloride?
Since we are required to determine the mass of sodium hydroxide required to synthesize 54 grams of magnesium hydroxide, this is our strategy. The mass of reactant to be converted to mole of reactant, we must use its molar mass. The mole of reactant to be converted to mole of the product, we must use mole ratio. The moles of the product to be converted to mass of the product, we must use its molar mass. The given mass of magnesium hydroxide is 54 grams, multiply its molar mass, multiply by mole ratio, multiply by molar mass of sodium hydroxide, the answer is 74 grams sodium hydroxide. To answer question B, how many grams of sodium chloride is produced from 212.9 grams magnesium chloride? We will apply the same strategy. The given mass of magnesium chloride is 212.9 grams, multiply its molar mass, multiply by the mole ratio, multiply by molar mass of sodium chloride. The answer is 617.5 grams sodium chloride.
Let's have activity 1. Solve the following problems by supplying the missing mass or mole ratios and compute for final answer. Let's go to activity number 2. Perform the needed calculations for these problems. Show your complete calculations in a clean sheet of paper and circle your final answer. Let's summarize our lesson for today. Fill up the necessary terms to show the mass-to-mass calculation from reactant to product via stoichiometry. Choices are inside the box.
And here are the answers to our write-up activity.
For our valuing, scientists could enhance their scientific skills by first, calculating the exact amount of reactants needed to synthesize a specific amount of product. 2. Avoiding guessing or overusing such chemicals to produce a certain compound. And third, keeping it sure that all of the resources are used well. Would you like to be a scientist someday? What are the simple things that you are doing right now that you could use as a basis for saying that you are a potential scientist? Let's get ready for post-test. Number 1. Which conversion factor do you use to calculate the grams of carbon dioxide produced by the reaction of 170.2 grams of C6H12O6 with oxygen? Choices are below. Number 2. Which of the following must be done first before solving stoichiometric problems? Read the choices below. It is the area of study in chemistry that examines the quantities of substances consumed or produced in a chemical reaction. The choices are below. 4. In this reaction, if 12 grams of aluminum oxide are consumed, how many grams of oxygen gas are produced? A. 2.1 grams, B. 3.1 grams, C. 6.1 grams, D. 8.1 grams. 5. In the reaction calcium hydride reacting with water, producing calcium hydroxide and hydrogen, what is the mole ratio that exists between water and hydrogen gas? A. 1:1, B. 1:2, C. 2:1, D. 2:2.
Here are the answers to post-test. What is your score? We hope that you learned something for today. Thank you and have a nice day.